Hello everyone, you are welcome to Mathematics Tour. This is the Cambridge Igcse Mathematics Paper 4, written in October-November 2024. There are 10 questions in this paper, but each question carries a lot of sub-questions, so to say. So if you are seeing this channel for the first time, please kindly subscribe to my channel by clicking the subscribe button. Also, like, comment, and share this video. I will drop the PDF solution as well as the past paper solved in this video in the comment section below this video. So to follow up with the solution, so you may want to have some snacks and some smoothie, okay, because it's going to be a very lengthy one, okay. So let's jump into the first question. Question 1A. Amvi buys a new car. The price of the car is $28,240. She is given a 7.5% discount. Calculate the amount she pays. So to approach this question, you could use several ways. Okay, so I'll show you two ways. So the first one is to calculate the amount of the discount. Okay, so the discount given, the amount of the discount will be equals to 7.5%. that is 7.5 out of 100 multiplied by the price of the car, which is $28,240. so if you input this into your calculator, so you should get $2,118. so that is the amount of the discount. So to calculate the amount she pays, so you have to subtract this from the price of the car. So the amount she pays, okay, will be equals to $28,240 minus the amount of the discount. That will be $2,118. so if you subtract this from this, so you should get $26,122. So that is one way. So you can use another method, and that will be this. So this 28,240, the price of the car is at 100%. So if you write 100%, implies the cost price of the car, which is $28,240. So if a discount of 7.5% is given, so we want to find the amount of the car. So the amount of the car when 7.5% is given will be 100%, will be at 100% minus 7.5. So that means we want to get the price of the car when the percentage is at 100% minus 7.5%. So 100% minus 7.5% will give you 92.5%. So what will be the price of the car at this percentage? So this has been discounted. Okay, so if we just kind of cross multiply, so we're going to have 100. So percent, we'll cancel percent here. So we're left with 100. Sorry, we have 100x to be equals to 28,240 multiplied by 92.5. So if we divide both sides by 100, so the 100 here, we cancel this, we're left with x, okay, which is the price of the car when the percentage is 92.5. that is a discounted price. Okay, so if you divide the numerator by the denominator, okay, so you should get the same answer, which is $26,122. So you have 26,122. So you can use any of these methods. Okay, so 1A, Roman figure 2. The fuel tank in the new car has a capacity of 45 liters. So this is the volume of the fuel in the fuel tank in the new car. Okay, so this is 72% of the capacity of the fuel tank in her old car. Okay, so that means from here we can see that for this 45,000, so 45, sorry, I said 45,000, 45 liters. For 45 liters, okay, it will be equals to, look at this statement, it is 72% of the capacity of the fuel tank in her old car. So that means it will be 45. This 45 will be equals to 72%. That is 72 out of 100 of means multiplication, okay, of our old car. Okay, so that will be, let's say this is multiplication. Okay, so let's say our old car is probably Y. Okay, you can say Y like this. So calculate the capacity of the fuel tank in her old car. So this is what we want to get, the value of Y. So if I cross multiply, okay, I can write this to be 45 equals to 72 rather, 72Y over 100. So I can now cross multiply. This will be 4500 equals to 72Y. So if I divide both sides by 72, okay, so this we cancel this, and if you input this into your calculator, you should get the value of Y to be equals to 62.5 liters. Okay, so put 62.5 here. So this statement is very important, the underlined one, so it helps in the solution. So let's go to part 1b. Ade buys a new car costing $28,000. He pays for the car using a finance plan. The finance plan is the deposit, then 47 equal monthly payments of $330, then a final payment of $11,490. Okay, so using this finance plan, Adi pays a total of $31,900 for the car. So this is the total amount paid. So calculate the deposit paid as a percentage of $28,000. Okay, so the total, okay, you can take the amount is the actual amount paid is $31,900. Okay, so we can take it from here. Okay, so the cost price of okay, that is the amount. Okay, we can write amount here, the amount. Okay, that is when you add this to this to this. Okay, the deposit plus the monthly payment plus the final payment. Okay, so when you add these three together, you should get $31,900. Okay, so then the monthly payment, you can write something like this: monthly payment. Okay, so monthly payment will be equals to 47 times $330. Okay, so 47 times $330. Okay, so this should give us $15,510. Okay, then the we have the final payment. The final payment is giving us $11,490. So this amount will be equals to the deposit plus the monthly payment which we have now, so plus the final payment. Okay, so from there I think we can come down here, so we can say that the final payment so will be equals to okay, we can just take the deposit directly. Okay, so the deposit, because that's what we want to find, it will be equals to the total the amount paid, which is $31,900. Okay, minus the monthly payment, which is the $15,510, then minus the final payment, which is $11,490. So if you do this, you should get the amount of the deposit. Okay, so this will give us 4,900. So this is the deposit. Now we want to write the deposit as a percentage of what? 28,000. So that will be 4,900 over $28,000. So multiply by 100%. Okay, so if you do this, you should get 17.5%. So straight away, so that means we have 17.5%. So let's go to the next question. That will be question 1C. A car travels 64 kilometers and uses 2.5 liters of fuel. It then travels 128 kilometers and uses 6 liters of fuel. So calculate the rate at which the car uses fuel during the whole journey. Give your answer in liters per 100 kilometers. So we need to get the total distance. So we also need the total fuel. So the total distance will be 64 kilometers plus 128. Okay, so this will give us the total distance, and if you add that, you should get 192 kilometers. 192 kilometers. Okay, then you can also get the total fuel. Okay, so you can get the total fuel. So that will be equals to 2.5 add 6, 2.5 add 6, and that will be 8.5 so liters. Okay, so haven't got this, so we can now say that the consumption per 100 kilometers. Okay, so we can write consumption per 100 kilometers will be equals to the fuel, which is 8.5 over the total distance, that is 192, then multiply by 100 kilometers. Let's just say 100 here. Okay, so if you do this, you should get approximately 4.43 to 3 significant figures. Okay, so that will be 4. Okay, there's point here. Okay, let's write this very well. 4.43. So 4.43 liters per 100 kilometers. Okay, so let's look into question 1D. At the start of 2021, the value of a car was $46,500. At the end of 2021, the value of the car was 20% less. Okay, so at the end of 2022, the value of the car was 15% less than its value at the end of 2021. That is at here. Okay, so calculate the value of the car at the end of 2022. So at the start of 2021, so the value of the car, okay, so you can say value. Okay, let's just write value is equals to 46,500. Okay, so this means the car is at 100%. Okay, that is the implication at 2021. Okay, so this $46,500 is at 100%. Okay, at the start of 2021, but at the end of 2021, the value of the car was 20% less. So if the value was 20% less, that means the value of the car at the end of 2021 was at 80%. That is 100% minus 20%. That would be at 80%. So what would be the value? So we can just say x, for instance. So if you percentage, you cancel percentage here. So if you cross multiply, so you're gonna get 100x to be equals to 80 multiplied by $46,500 Okay, so if you divide both sides by 100 to get the value of the car when it was at 80%, so this will cancel this. So x is equals to this will give us $37,200. So that means at the end of 2021, okay, so the value of the car was at 80% and it is equals to 37,200. So the last statement here, at the end of 2022, the value of the car was 15% less than its value at the end of 2021. So the implication is that this 37,200 is at 400%, okay? So that is at the beginning of 2020, at the end of 2021, okay? So it implies 37,200, okay? But at the end of 2022, the value of the car was at 15% less than its value at the end of 2021. So this is the value of the car at the end of 2021 and is at 100%, okay? So if you now have 15%, if it is 15% less than its value at the end of the 2021, that is the value at the 2022, at the end of 2022 is 15% less than its value at the end of 2021. So that means we need to get the price at 100% minus 15%, that would be 85%. So what would be the value of the car at 85%? Okay, so percentage, you cancel percentage, so you can cross multiply. We have 100x to be equals to 85 multiplied by 37200. So you can divide both sides by 100 to get the value of the car, okay, at the end of 2022. Okay, so this will cancel this. So probably you can use another letter for this. You can use y. Okay, so I can use y here. Okay, that will be y. So y will be equals to, if you input this into your calculator, you should get $31,620. So that will be the value of the car at the end of 2022. So let's put 31620. Okay, so let's go to the next question. Excuse me, that will be question 2. The table shows some values of y equals to x to the power of 3 plus 4x squared minus 4. Okay, so here what you need to do is to input this expression, okay, that is the right hand side, into your calculator, okay, and set the starting and the ending part of it, okay, and the step is 1. So if you do that, you should get all the values straight away. So here should be -4 and here should be -1. So that is what we need. So we are done with part A. Okay, part B, on the grid, draw the graph of this. Okay, so we have the table. Okay, we have the readings, okay, from the table. So when s equals to -4.5, so -4.5 is here. So y is equals to -14.1. So 14.1. So don't forget that the value of a line here is 5 divided by 10, okay, on the y-axis, okay, so that will be 0.5, okay, and the value of a line along the x-axis will be 1 divided by 10, that will be 0.1, okay. So for x to be equals to 4.5, so that means it is here, this is -4, so 4.5 will be the middle here, okay. Then y is equals to -14.1, so this will be, don't forget the value of a line is a half along the y-axis, so 10 will be here. So if you have 1, 2, 3, 4, 5, so this is 10, let's count 1, 2, that will be 11, 1, 2, that will be 12, okay, 1, 2, that will be 13, 1 2, that will be 14. Okay, so we need 14.1. Okay, so if you go to the next one, it's going to be 15. So you can just take a point here, a little bit down there. So that will be the point there. So the next point will be when x equals to -4. So y is equals to -4. So since the value of a line is half, so we need 7 lines. To get -4, so that will be 8 lines, okay? Because that will be -4. So this is 5. So it will be 6, 7, 8. So it will be here when s equals to -4. So y is equals to -4. Okay, so it will be 8 lines. That is half of 8 will be 4. Okay, the next one when s equals to -3. So y is equals to +5. So it will be up here, this spot here. And when x equals to -2, y is equals to +4. So we need to go up. So it will be 8 lines. So this will be here. This is 8 against, that is 8 lines, which is equivalent to +4, okay, against -2, -2 against 4. Okay, so the next one is -1 against -1. Okay, so 1 will just be 2 lines, so it will be 1 here, 2, so -1 against -1, so it will be exactly this spot. Okay, then when it is 0, it is -4. So 0, -4 will be 8 lines downward, so it will be here. Good. Then when it is 1, okay, when s is equals to 1, so y is equals to +1 as well, so it will be 2 lines upward here. So this is the spot. And when is equals to 1.5, so that is the middle here, s equals to 8.4. So this will be 8.4. So don't forget, this is 5. 1, 2, that will be 6. 1, 2, that will be 7. 1, 2, that will be 8. Okay, then we need 0.4. Okay, just a little bit up here. Okay, so don't forget, 2 lines will give you 1 along the y-axis. So this is 5. 1, 2, 6. 1, 2, 7. 1, 2, 8, then a little bit up. Okay, so we need to connect these together. So as you can see, it's something like this. So this is the curve upward. So I'm going to join or connect this point together and show you the results. So we are going to have a kind of this. So you can use a French curve, okay, to have a perfect one. So this is what we're going to get here. So let's go to the next part. That is part C, Roman figure 1. Draw the tangent to the graph at the point x equals to 1, y equals to 1. So this will be x equals to 1, y equals to 1 here. So you can take a ruler and a pencil, then you draw from here like this. So you can draw something like this, very close. Okay, then I need to extend my line here. Okay, so I can just take this one like this. So it touches the curve at a point, okay, that is at x equals to 1, y equals to 1. So you can extend this like this. Okay, so let's test this one here. Okay, I think I'm okay with this. Then you need to pick 2 points. So I can pick this, let's say this point here. Okay, I can just pick a point here. So let's pick this. Okay, I'm looking for the exact point that we not. Okay, I think I'm good with this. So I can pick this point here, this particular point at x equals to this. Then another one I could pick think let's see. Okay, I'll just go with this here. Okay, I think I'm okay with this here. So we pick this point here, this particular one. Okay, and this particular one here. Okay, good. So I can just draw a broken line like this to trace them, something like this. Okay, and let's trace this one too. So good. Okay, so what is the value of x here? What is the value of x here? Okay, so what's the value of y here? What's the value of y here? So those are the things I need to use for my gradient. So at this spot, x is equals to, okay, let's read this one, x equals to 0.5. So x1, I can just have a summary here. x1 is equals to 0.5. Then x2 will be equals to here, that is 1.6. Okay, so x2 is equals to 1.6 from here. Okay, good. So let's say the value of y. So y1 will be equals to this one here. This is minus 4. Okay, this will be minus 4. Then y2 will be equals to, let's say the value of y2 here. So a little bit, this one, that will be say about it's a little bit more than 6, but I can take it to be maybe 6.1 or just 6. So let's take 6.1. Okay, so these are the values I need to use to calculate the estimate of the to calculate the gradient. Okay, so let's see. I can now scroll down a little bit. So yeah, so x1 is equals to something, then x2 is equals to something, so y1 is equals to something, and y2 is equals to something. So let's scroll up and see it again. 0.5 and 1.6, 0.5 and 1.6 for x1 and x2 respectively. So for y1 we have minus 4 and 6.1. So we have minus 4 and 6.1. So the formula for the gradient, so let's say the gradient is m, and it will be equals to y2 minus y1 over x2 minus x1. So this will be equals to 6.1 minus, then minus 4, everything over, that's 6.1 minus 4, then it will be 1.6 minus 0.5. Okay, so this will be 6.1, okay, plus 4 over, this will be 1.6 minus 0.5, that will be 1.1. So finally it will be this 10.1 divided by 1.1. So if you input this into your calculator, you should get 9.18. So approximately 9.18. So this would be the gradient. So 9.18. So you can get a different answer. It doesn't matter, okay, because it is an estimate of the gradient, not the actual gradient. So it will fall in a range, okay. So you can get 7, you can get 10, you can get so some numbers in a specific range, okay. So there's no specific answer. So that is why it is an estimate of the gradient, okay. So let's go to the next question. That will be question 2D Roman figure. Okay, I think question 2D. Okay, so we have only one question here. So by drawing a suitable straight line on the grid, solve the equation this. Okay, so don't forget that the original equation is y is equals to x to the power of 3 plus 4x squared, then minus 4. So if you have this now, and this is given, the new equation is, let's say, x to the power of 3 minus 4x squared minus x minus 6, okay, so equals to 0. So how can we write this to be like this? Okay, so what we need to do is to say x to the power of 3 minus 4s squared. So I want to get minus 4 here, so I can break minus 6 to minus 4 minus 2, then minus x. Okay, they are still the same. Then I can now equals to 0. Then I can now take this to the right hand side, then also take this to the right hand side. So I'll be left with x to the power of 3 minus 4x squared, then minus 4 equals to plus x, then plus 2. Okay, so if you look at this now, this one is equals to y, so I can say y, so it's equals to x plus 2. So that means the solution of this equation lies at y equals to x plus 2. Okay, so we need to draw, so y is equals to x plus 2. So if you compare this with the general equation of a straight line, y is equals to mx plus c. So you see that m is the gradient and it's equals to 1, and c is the intercept on y-axis, and that will be equals to 2. Okay, so you can say 1 over 1, rise once and run once. That is the gradient. Okay, so let's go to the let's go back to the grid, okay, which is this now. So we want to draw that equation y equals to x plus 2. Okay, so the intercept on y-axis is positive 2. So don't forget a line here, so let's count 4 lines. So 1 2 3 4. Okay, so that would be 2, so it will be here, so 2 will be here. Okay, so that means the excuse me, the intercept on y-axis is this spot, okay, and the gradient is 1 over 1. So you go up once and you run once. So let's go up once from here. So that will be 1 2, that will be 1. Okay, then let's run once. So this will be this now. Okay, because 1 is 2 lines along the y-axis, and 1 is here, as you can see. So if you go up, 1 will be 1 2 2 lines, then 1 step will be, let's see, 1 2, then it will come here. Okay, so this will be the next point. So since you have these 2 points, okay, it's sufficient for you to draw the straight line. But you may want to have another another point, so you can just count 1 2, that will be 1 up, then 1 to the right like this, okay, along the x-axis. We can have another point here. So let's connect this point together. So from here, okay, I can just connect these 3 points together, okay, something like this. So let me see why this one is not on the spot. You see from here, you have 1 2. Oh, sorry. So this one is not on the spot, because from here, 1 2. Can you see the essence of drawing that? It should be here. So that is correct. Okay, so it should be here. 1 1 2 1. So it should be here. Okay, so that's the essence of having more than 2 points. Okay, so now the solution will be at this spot here and at this spot here. So it's an estimate. So what will be the value of x here? Okay, so and what will be the value of x here? So if I trace this one down, okay, so that will be the solution. So from here, minus x x will be minus 1 point something here. So let's see for this one, it is this spot here. Okay, that is this one here. So that will be minus 1 minus 1.1 minus 1.2. Okay, so here my x is equals to minus 1.2. Okay, then let me just write it here. X equals to minus 1.2 and x equals to the second one. So let's come down here. That is 1.1, 1.2, 1.3. So x equals to 1.3. So that will be the value of my x. Okay, let's see again here from this. This is 1.1, 1.2. Okay, so that will be x equals to 1.3. Okay, so that will be the value of my x there. Don't forget that you need to draw a perfect curve, okay, for you to have accurate results. Okay, so I'll take x to be equals to negative 1.2 and negative 1.2 and positive 1.3. Okay, so it will be this x. Oh, sorry, should I have 3 points? Let's go. Yes, that's correct. See, I didn't complete this line. So you can extend here. So that was a mistake. Okay, so we can connect this like this. Good. Okay, so this will be the third point here. Sorry for that, I didn't complete the line. Okay, so the third point will be here. Okay, so that will be minus 3 point, let's see, minus 3.9. So minus 3.9. Okay, so minus 1.2. So x will be equals to minus 1.2, or x equals to minus 3.9. And I think the third one, so let's go back. The third one is 1.3. Okay, so x equals to 1.3. Okay, so these are the values of x when you have this equation. Okay, so let's go to the next question. That will be question 3. Okay, simplify 3m minus 5n minus 4m plus 8n. Okay, so this and this will give you negative m, that is minus m. Okay, then this and this will give you positive 3n, which you can write as 3n minus m. So if you want 3n minus m, so around figure 2, you have this. So this is the same as 3 to the power of 4, a to the power of 2 times 4, then c to the power of 3 times 4. So this will give you 81, that is 3 to the power of 4, then a to the power of 8, then c to the power of 12. So I have 81, a to the power of 8, then c to the power of 12. Okay, so now we got 3. So we need to just find the LCM of the lowest common multiple. Okay, the lowest common multiple of 5, 10, and 15, that will be 30. So 30 divided by 5, that will be 6. 6 times 4, that will be 6 times 4x, rather, that will be 24x. Then minus 30 divided by 10, that will be 3. 3 times 3x, that will be 9x. Then plus 30 divided by 15, that will be 2. 2 times 2x, that will be 4x. Okay, so 24x minus 9x plus 4x, sorry, this should be 4x. So 24x minus 9x plus 4x, so that will give you 19x out of 30. So we have 19, 3, we have 19x out of 30. So part B, the isosceles triangle. This isosceles triangle has a perimeter of 35.5 centimeters. So find the value of A. So this will also be 3A plus 2 because the two sides are equal. Then we can now say that the perimeter is the addition of the distance around the isosceles triangle. So for that reason, I can just say 35.5 should be equals to the addition of the three sides. So this will be 3A plus 2 plus 3A plus 2 plus A. Okay, this and this add up to 6A and this 7A. So 35.5 will be equals to 7A. Then this and this add up to 4. Okay, so let's solve for A. Subtract 4 from both sides. So 35.5 minus 4. So that would be 31.5. Okay, so you have 31.5. Then it's equals to 7A. Then divide both sides by 7. So if you divide both sides by 7, so the value of A should be equals to 4.5. Okay, so A is equals to 4.5. So let's go to the next question. That will be part C. So using the quadratic formula, solve this. Okay, so if you compare this with the general equation of quadratic equation rather, so that will be ax squared plus bx plus c equals to 0. So this is the general form of quadratic equation. Okay, you see that a is equals to 5, then b is equals to -4, and c is equals to -3. So using the quadratic formula, so x will be equals to minus b plus or minus b squared minus 4ac. So this will be square root, then everything over 2a. So if you key in the values, we're going to get minus 4, okay, then plus or minus square root of b squared, okay, that was minus 4 all squared like this, then minus 4 into a, then into c, that is -3, then everything over 2 into a, that will be 5. Okay, so we can simplify this now. So let's write it here. So that means x will be equals to, so this and this will become positive 4. So you have 4 plus or minus, this will be 16. Okay, so square root of 16, then minus 4 times 5 times -3. So that should give you 20 and then 60. So that is positive 60. Then over 2 times 5, that will be 10. Okay, so this will be equals to 4 plus or minus square root of, this should be 76, square root of 76, everything over 10. Okay, so this should be equals to 4 plus or minus square root of 76 is 8.7178, 8.7178 over 10. Okay, so from here you can just continue like this. So this will be 4 plus 8.7178 over 10, okay, or 4 minus 8.7178 over 10, okay. So this will give you, if you add these together, okay, and divide by 10, so you should get approximately 1.27, and here you should get minus approximately minus 0.472. Okay, so x is equals to 1.27, or x equals to minus 0.472 to 3 significant figures. Okay, so part D, solve these simultaneous equations. You must show all your working. So you can call this one equation 1. So you can call this equation 2. So you can just say that 1 is equals to 2. That's equation 1 is equals to equation 2. So that means you can say x squared minus 4x plus 5. That's equation 1 is equals to 2x minus 3. So if you do this, so you can say x squared minus 4x. So let's bring 2x to this side. It will be minus 2x plus 5. Then let's bring 3 to the left hand side. That is plus 3 equals to 0. Then we can now do this. X squared minus 6x plus 8 equals to 0. Then we can now use factorization method. So this will be 2 times 4, then minus 2 minus 4. Okay, so we can actually say x squared minus 2x minus 4x plus 8 equals to 0. So this will be factored into x minus 2 minus 4 into x minus 2 equals to 0. So it means x minus 4 into x minus 2 is equals to 0. So that means x minus 4 equals to 0, or x minus 2 equals to 0. So from here, so x equals to 2 or x equals to 4. So when x is equals to 2, so what will be the value of y? So we need to substitute. So y is equals to 2x minus 3. So we can use any of the equations, but I'm using equation 2 there because it's easier. So this will be y equals to 2 into 2 minus 3. That will be equals to 4 minus 3. That will be equals to 1. Okay, so I have x equals to 2 when y is equals to 1. Okay, then also we can just do another one. So I think I can do it here. So let's partition this place. So when x equals to 4, so we have y equals to 2 into 4 minus 3. That will be equals to 8 minus 3. Okay, so that will be equals to 5. Okay, so when x is equals to 4, y is equals to 5. So this is the solution. Okay, so let's go to the next question. That will be question 4a. The angles of a quadrilateral are w, x, y, and z. The ratio of angle w to the sum of the other three is equals to 3 to 5. Find the value of w. Okay, so to get there, so the total angle here, total angle will be equals to 360 degrees. That is sum of angles in a quadrilateral. Okay, and total ratio equals to 3 add 5 equals to 8. Okay, so how many lots will you see? So lots of 8 in 360 degrees will be 360 degrees divided by 8. Okay, so if you do this, you should get 45. Okay, so that's good. So we can say that, okay, w ratio x plus 5, x plus y rather, plus z. So this is the second quantity. Okay, so we have 3 to 5. Okay, so since we have 45 lots in 360 degrees, this will be times 45. So this will be times 45. Since we need the value of w, so we just need 45 times 3. So that will be 135. Okay, for this one. Okay, so that is 3 times 45. So equals to 135. So that is what I did there. So 135. Okay. So the next one will be part B. this is circle theorem or circle geometry. So circle geometry. Okay. A, B, C, D are points on a circle. PQ is the tangent to the circle at A, as you can see there, at point A there. Then B, M, N, D is a straight line. B, M, N, D, as you can see. So B, M, N, D, this particular one, good. Okay, so angle ACD is equals to 49 degrees, as in there. Then angle AMB is equals to 105 degrees, and angle PAB equals to 45 degrees. Find angle BAM. Okay, to get angle BAM, let's see, angle BAM. So we want to get this angle. Okay, so to get this angle, so you must know this angle, which is given as 105 degrees, and you must know this. Okay, so to get this angle, okay, so this angle and this angle, they are in the same segment because they are produced by what? By the arc AD. Look at it, A. Okay, like this. So the same thing for this. So they are both produced by the arc AD. So that means I can say this place is also 49 degrees. So I cannot get this now. It's easy. Okay. So angle BAM will be equals to BAM. Okay. Will be equals to, that is 180 minus 105 minus 49. Okay. So that is 180 minus this will give us angle BAM. That is very straightforward. And you may want to write this like ACD, the one I showed you, equals to ABD, then equals to 49 degrees. So I showed you earlier. Okay, so if you do this, this should give you 26 degrees. That is the value of BAM, 26 degrees. Then we figure 2, find the angle BAD. So let's see, angle BAD, that is the whole of this angle. Okay, but you see that angle BAD be equals to let me see, BAD will be equals to the addition of this angle BAM and MAD. Okay, so that is what we are going to get there. So I think we can write it down. We can write it here. So angle BAD, so it is our solution. BAD, okay, will be equals to this is BAD, it will be equals to BAM plus MAD. Okay, so it will be equals to BAM, that is this angle, plus MAD, okay, or DAM, anyone, they are both the same. So we already calculated BAM, which is 26 here, okay, plus, so we need to calculate or find the angle MAD. So to get angle MAD, so we need to, that is, we want to find this angle here, MAD. Okay, so to get MAD, so we need to know this angle. Okay, we need to get this angle. Okay, but look at these two angles, this one and this one. They are opposite angles to this 105. Okay, so from a theorem, from triangle AMD, okay, you see that 105 is an exterior angle, and there's a theorem, the exterior angle of a triangle is equals to the sum of the interior opposite angles. So 105, okay, will be equals to MAD, okay, plus AD, Okay, so 105 will be equals to MAD. Now can get MAD, so plus ADM. So to get ADM, okay, so ADM is an if you look at this angle here, angle 45 degrees here, this particular one, okay, so okay, I think we can get ADM first. ADM will be equals to 45 degrees. Why? They are angles in the same segment. Sorry, angles in alternate segments. So when the angle between a chord and a tangent is 45 degrees, okay, so it's in the same segment as this, okay. It's in alternate segment rather. So I kept on saying the same segment, alternate segment. So when you see an angle in between a tangent and a chord like this, let's scroll up a little bit, this particular one. Okay, so if you have your triangle like this, okay, so this angle here, okay, will be an alternate segment to this. So that means this place is also 45 degrees. So you can say that ADM is equals to 45 degrees. That is angles in alternate segments. You can say alternate, then segments. Okay, so that means 105 is equals to MAD plus ADM is 45 degrees. So MAD will be equals to MAD will be equals to 105 minus 45 degrees. So which is equals to 60 degrees. Okay, so then I can now come here that MAD is equals to 60 degrees, then this will be equals to 86 degrees. So it will be 86 degrees straight away. So part B, give a geometrical reason why BD is not the diameter of the circle. Give a geometrical reason why BD is not the diameter of the circle. Okay, here if BD was a diameter, okay, so the angle here should be this angle here, the whole of this, that is angle BAD should be equals to 90 degrees because it will be angles in a semicircle. Okay, so for that reason, so you can say that BD, since BD is not a BD is not a diameter, okay, so because angle BAD, okay, so it's not equals to 90 degrees, or you can just say simply angles in a semicircle, angles in a semicircle. Okay, so they mean they both mean the same thing, semicircle. So that would be the solution there. So let's go to the next question. That's part C. So here, A, B, C, and D are points on a circle center O. TA and TC are tangent to the circle. OA equals to 6.75 centimeters and OT is equals to 11.5 centimeters. So OA, so this one here is equals to 6.75 and OT, this one here is equals to 11.5. Okay, so I think I can draw something out. Okay, so let's draw something here. Can have a straight line here like this. Then let's have this one here. And probably have this. Okay, so this will be here like this. Okay, and this will be, sorry, let's arrange this one back. So, and this will be here. Okay, that is the 90 degrees. Okay, so this is A, this is O, and this is T. So this will be 11.5 and this will be 6.75. Okay, so we want to show that the angle AOC, this particular angle, okay, is equals to 108.12 degrees correct to two decimal places. Okay, so we can call this one theta. So that is this one to be theta. So this one too will also be theta. So that means we need to find the whole of this theta. Okay, so once you know the value of theta, so we just multiply it by 2. So using Pythagoras, or let me say trigonometric ratio, so this will be equals to this is opposite, this is adjacent, and this is hypotenuse. Okay, so we can use cos theta. So from here we can say cos theta is equals to adjacent over hypotenuse like this, so which is equals to 6.75 over 11.5. So you can see that, okay, let's write this again, cos theta is equals to 6.75 over 11.5. Then from here I can say that theta, okay, let's just continue from here. So you can say theta equals to cos inverse. If you take cos inverse of both sides, so we'll be left with theta here into bracket 6.75 divided by 11.5. Okay, so from here you can now input the whole of this into your calculator and get the value of theta. So theta will be equals to 54.0587 to 4 decimal places. And from here now, so angle AOC will be twice this, 2 into 54.0587. Okay, and to 2 decimal places, that will be equals to 108.21 degrees. So that has been shown. Calculate the length of the minor arc ABC. So we need this angle. That is the value we just shown. Okay, so that means we have something like this. Okay, so this is 6.67, 6.75 rather, 6.75, so 6.75, and the angle here is 108.21. Okay, so we want to find this minor arc. Let me see, ABC. So this will be the origin ABC. So good. So that's what we want to do. So the length will be equals to that theta, that is 2 theta, or let me just say this angle here, AOC, okay, instead of using 2 theta, AOC over 360 times 2 pi r. So this will be equals to 108.21 over 360 times 2 times 3.142 times 6.75. So you can input this into your calculator straight away and you get 12.7 centimeters. So round figure 3, calculate the area of the major sector, okay, OCDA. So OCDA, so we need the reflex of this, okay, that's the angle. Then I think that's the only thing. So the formula is this. So the area of OCDA, the major sector, will be equals to a reflex of that is reflex of AOC, then over 360, then times pi r squared. So this will be equals to 360 minus 108.21 over 360, then times 3.142 times 6.75 squared. Okay, so this will give you, okay, we can simplify this to 251.88 over 360, then times 3.142 times 6.75 squared. So you can input the whole of this into your calculator to save time, and you get the answer to be 100 squared centimeter. Okay, so that would be that. So let's go to the next question. That would be question 5a. So the cumulative frequency diagram shows the information about the distance traveled by each of 80 motorists in a month. Okay, so if you see this, use the cumulative frequency diagram to find an estimate for the median. Okay, so for the median, we need to get to the median class. Okay, so the median class equals to 80 out of 2. Okay, that's the 40th. Okay, the 88 minus this, that will be the 40th. Okay, you can just write it like this, the 40th. So if you go to the 40th will be this. Just draw a line from here like this particular one, then against this, if you trace it down, to be this exact one like this. Okay, so the value of a line here along the x-axis, it will just be 40. Okay, so a line here is 40. Okay, and along the y-axis, a line is 2. Okay, so this will always help you to calculate the value of any given number of lines. Okay, so from here now, 48. So we want to get this value now. So what will be the answer here? So this will be equals to 1,200 plus the, how many lines do you have here? So this is 1,200. 1, 2, 3, 4, 5, 6. Okay, 6. So that will be 6 times 40. So let's check again. Let me see if I have the correct one here. So the 48 will be this. Okay, yes, I think this should be 7 lines. That will be 1, 2, 3, 4, 5, 6, 7. So this will be 7. So that will be 1,200 plus 40 times 7. So we have 7 lines. Okay, and each is 40. So this will give us 1,200 plus 40 times 7. That will be 280. So that will be equals to 1,480. So we have 1480. Okay, so the interquartile range. So the interquartile range is equals to Q3 minus Q1. Okay, so we can get Q3. Okay, so Q3 is let's say 3. So we can just write something here. Q3 is equals to 3 over 4 of 80. That would be the class. So if you do this, that's the 68th. The 68th. Okay, so you can just draw a line like this. The 68th. And it's easy. It's just the 68th. That would be Q3. And then Q1 will be the 20th. Just this and this. Okay, so pretty easy. So you don't need to do any calculation if you really understand it. So this one, okay, and against this one, okay, then this one, that will be for Q1. It's pretty easy. Then against this one here. Okay, so if you take the readings, so Q3 will be 1,600, and then Q1 will be equals to 1,160, because this is just about 800. Yeah, so you have 1, 2, 3, 4, 5, 6, 7, 8. So 8, 9, then 9 times 40, that's 360. Then add so that would be 800 plus 9 times 40. 9 times 40 is 360. 360 add 800, that would be 1160. So that is how to get that. Okay, Q3 is equals to 1006. Q3 is equals to 1600, and Q1 will be equals to, just like what I told you, 800 plus 40, that's value of a line, times 9. So this will give us 360. Okay, so 360 add 80, so at 800 rather, so this will be equals to 1160. So we can actually do Q3 minus Q1. So Q3 minus Q1 will be 1600 minus 1160. So that will be equals to 440. So we have 440 here. Okay, Roman figure 2. So one of these motorists is picked at random. Find the probability that the motorist travels more than 1,800 kilometers. More than 1,800 kilometers. Okay, so let's see from the grid, more than 1,800 kilometers. So we need to identify 1,800 kilometers from the graph. So this is, don't forget that a value of a line is 40 along the x-axis. So 1,800 will be, so this is 1,600. So I need 200. That will be 40 times 5. That's 200. So it will be here. So this is 1,800 here, the middle. So I can just draw this line from here like this. Okay, so sorry, to this spot here. Okay, so if I take it here now to see the corresponding value of the cumulative frequency here. Okay, so it is here. Oh, sorry, let's undo that. So this should be somewhere here. Okay, on that line. Okay, good. So now we can, this is this particular spot will be 72 if you calculate it. So don't forget that the value of a line here is 2. So this will be 70, and then this particular spot is 72. So above will be 80 minus 72. That will be 8. So that means it will be 80 minus 72. That's what we need, over 80, and that will be 8 out of 80. So that will be equals to 1 out of 10. Okay, so it's 1 out of 10. Okay, so part B, the distance around a racing track is 5.104 kilometers. The time taken by a car to complete one lap of the track is 1 minute 18 seconds. Okay, so calculate the average speed of the car. Give your answer in kilometers per hour. Okay, so we know that the average speed will be total distance over total time taken. So speed equals to distance over time. Okay, and the distance is equals to 5.104. So, but the time, we need to convert the time. Okay. Okay. So the time is 1 minute. Okay, 18 seconds. So 1 minute, then 18 seconds. So to convert them to hours, so 1 minute to hour will be, to an hour, it will be 1 divided by 60, then plus 18 seconds to an hour, it will be 18 divided by 60, then divided by 60 again. So that means it will be divided by 60 times 60, that will be 3600. So if you solve this, you will get 13 over 600. So that will be in hour. So speed is equals to distance, that is 5.104 times divided by, rather. Okay, we can just do this straight away. Okay, so divided by 13 over 600 will be the same as multiplied by 600 over 13. So we find the inverse straight away. So you can actually do that. Okay, so if you input this into your calculator, so you should get 236. Okay, so three significant figures. Okay, so 236 kilometers per hour. So let's go to the next question. That would be question 5C. Okay, question 5C. This is the top speed. V is the speed of each of 160 cars is recorded. The histogram shows the information. Okay, as you can see here, show that there are 8 cars with a top speed in the interval 120 between 120 and 160. So that is here and here. Let's say here and here. Okay, so if you trace this one here now, so we need to get the frequency density here. So what is the frequency density here? So we have 0.5 here. That means the value of a line along the frequency density will be 0.5 divided by 10. So that will be 0.05. So that's the value of a line here. Okay, so how many lines do we have here? 1, 2, 3, 4. So the frequency density, shortened to FD will be equals to, that will be 4 times 0.05 for this. Okay, so that is the frequency density. So we have a formula here. So the formula is this: the frequency density is equals to frequency over the class size. So which implies that frequency will be equals to frequency density multiplied by the class size. So the frequency density is this. So I'll just put it as 4 times 0.05. That will give me the frequency density of this spot. Then multiplied by the class size. That will be 160 minus 120. That will be 40. Okay, so times 40. So this will be equals to 8. Okay, so we've shown that there are 8 cars, okay, with a top speed in the interval of 120 and 160. Okay, so we have done that. Then calculate an estimate of the mean top speed you must show when you're working. Wow, this is going to be a little bit long, but because we need to tabulate. Okay, sorry, let's redraw that. So we need to tabulate. So we can draw a line like this. Okay, good. So I think I can redraw that again. So if you draw a line like this, good, then we can now have something like this as well. So we're going to have the class interval. Okay, so I think I can, okay, let me divide 1, 2, 3, 4, 5. I think I will need 5 lines. Okay, so let's do this for the class interval. Okay, or let's have more space. Okay, sorry. Okay, so I can have more space. Sorry for that. So I can have more space like this for the class interval. Then I need another column for the average when I find the average of the class interval. So I think this should be enough. Then I need a column for the frequency. Then I need a column for the product of the frequency and the mid value. Okay, I think okay like this. So here it will be for the class interval, and this will be the mid value. So I can denote that by x. So I have the frequency, so that will be f. Then I have the product of f and x, so which is what I need. And Okay, so for the class interval, let's go to this. We have the first one that is between 120. So 120 is less than v, and v is less than 160. That will be the first one. So that is 120 is less than v, the speed, and is less than or equals to 160. So the next one will be 160 is less than v. So let's say the range. So that is from here to here. So 180, that will be the next one. Less than or equals to 180. So the next one will be 180 is less than v, and v is less than or equals to between 180 and you can see here. Okay, that is 200. So this is the next one. So then we have 200 and 240. So I can just write them together. So 180 is less than v, and v is less than 200. Okay, so then the next one will be 200 is less than v. Sorry, less than v, and v is less than or equals to, I think, okay, down this at 240. Okay, and the last one will be 240 less than v, and v is less than 300. That's the last one. So less than or equals to 300. So I think I can as well draw a line like this for this one. Okay, I think I can write that. Okay, I'll correct it. Then another one like this. And another one. Then finally have this. Okay, so I can just take this one again here. So it will be 240 less than v, and v is less than or equals to 300. Okay, then I think I'm okay here. So I can just write this one to again. So less than 180. So this one too, less than or equals to 200. So I think we are good now. Okay, so to get the mid value now, so 120 add 160 divided by 2. So this will be 140. Add these 2 divided by 2. That will be 170. Add these 2 divided by 2. That will be 190. Add these 2 divided by 2. So that will be 220. Then add these 2 divided by 2. That will be 270. Yes, the most challenging now is to get the frequency. Okay, so the first one, the frequency of the first one is this, which is 8. Okay, so I'll just calculate one more, then I'll fill up the column. Okay, so we want to get the frequency density. Okay, I want to get the frequency of the next one, that is for this interval when your 160 is less than v, and v is less than or equals to 180. So for this one, okay, so we need to get the frequency density, because that will help us, just like what we did for the first one. Okay, so we know that the frequency, okay, I think I can write here. So the frequency is equals to the product of the frequency density and the class size. So that's what we're going to do for each of these. Okay, so I'll just do only one. Then for this now, the frequency density of this bar now, of this class, will be equals to this is 1 plus 1 2, that is 0. Don't forget, a line is 0.05 here. 0.05 times 2 plus 1. So that will be the frequency density. I think I can just write here. So the frequency density of this class, this particular class now, so will be equals to 1 plus the value of a line is 0.05, and I have times 2. I have 2 lines. Okay, so this will be the frequency density, and the class size will be 180 minus 160, so that will be 20. So this will give me the frequency. So if you multiply this, okay, this and this will be, well, this will be 1.1, okay. So this 0.05 times 2 will be um, 0.1, so 0.1 plus 1, so it will be 1.1 times 20. So the frequency density here for the next class, this one is 1.1, okay, so that is 1.1, okay. So times 20, so the frequency will be equals to 22, okay, it will be equals to 22. So that means the frequency of this class will be 22. So you can fill up the diagram in order to save time. So you find the frequency density of the remaining bars and multiply by the corresponding class size, okay. So this will be the next one will be 36. You have 36. So this will be 64, and the last one will be 30. Then I cannot get the product of x and f. So this will be 1120. So this will be 3740. So this will be 6840. This will be 14,080, and the last one will be 8,100. So already I know that the summation of the frequency should be equals to 160, okay, as we were told from the beginning. That will be 160, and if you add all this together, you should get 160. So I don't need to waste my time. So then the summation of the product of f and x will be equals to addition of this colon, okay, and that will be equals to 33,000 and let's see, 33,880. So 33,880. So to get the mean, so denoted by this, it will be equals to 33,000 summation fx, which is 33,880 divided by 160. So this will be equals to 211.75. So this is the direct answer. So there's no need to approximate. So you have 211.75 kilometers per hour. So let's go to the next question. That will be question 6. So work out this. Okay, I need to open this bracket. This will be 6 against negative 10, then minus 2 against negative this. So this will be equals to 6 minus 2, then this will be minus 10. So minus and minus will become positive, plus 7. Okay, so this will be equals to 4 against negative 3, 4 against negative 3. And the next one will be this. Mn, so we can have a rough sketch. So Mn will be something like this from M to N. So you just have something like this. Okay, good. So if this is M and this is N, okay, good. So you can have something like this to this place. Then you can have something like this. Okay, so the direction like this and like this. Okay, so Mn is negative 6 against 4, and then M is the point 2 comma negative 5. Okay, so that means you move 6 times towards the left hand side here. Okay, then go up 4 times. Okay, so find the coordinates of N. To get the coordinates of N, okay, that means you are moving from 2 6 times. Okay, so let's say you have 2 here, then you move 6 times to this towards this direction. So let's say you have this, now it will be 1 2 3 4 5 and 6. Okay, so this is 2. The next one will be 1 0 negative 1 negative 2 negative 3 and negative 4. So it will be negative 4 by the time you get here. Okay, so and you have to go up again, so 5 times from negative 5. So let's say we have, okay, I can do it here. Negative 5 is here. So you want to go up how many times? 4 times. So from here you have 1, 2, 3, and 4. It will be here. Negative 5, negative 4, then negative 3, negative 2, and negative 1. So it will get to negative 1. So this is one way of doing it. So you could as well do minus 6 plus 2. That would be negative 4. And you could as well do negative 5 add 4. That would be negative 1. So you can do it straight away like that if you want to do it algebraically. Then Roman figure 2, find the modulus of, or the magnitude, okay, of mn. So mn could be written as this. I think okay, let's say negative 6x then plus 4y, or you can just say minus 6i plus 4j, whatever. Okay, so the magnitude now, okay, will be equals to the square root of minus 6 squared, okay, the whole of this rather, so you need to be very careful. So the whole of this, then squared plus 4 squared. So if you input this into your calculator, you can get the answer straight away, or you may want to simplify this a little bit. This will be 36 plus 16, so which is equals to square root of 52, and that would be 7.212 significant figures. Okay, so let's go to the next question. At C, OACB is a trapezium with OB equals to 2AC, OA equals to vector A, and OB is equals to vector 2C. AP ratio PB equals to 4 to 1, and AQ equals to 4 over 5 AC. Write each of the following in terms of vectors A and C. Give each answer in the simplest form. Okay, so I think we can adjust some things here before we start. So if OB is twice AC, so and OB is 2C, so that means vector AC in this direction will be equals to vector C. Okay, and for this one, okay, we'll come to this one because to get the value of AP and PB, so we have to know the length of AB. So we'll come to this one, and for this, AQ is equals to 4 over 5 AC. So we can easily do that. Since we know AC to be C, then AQ, okay, so we can write something here. AQ in this direction will be equals to 4 out of 5 of AC. So an AC is C, so we can put C here. Okay, so that is pretty easy. Okay, so I'll just come back to this one later once I know the length of AB. So let's continue with the question. So AB, so we are finding AB. So AB will be equals to AO plus OB. So this will be equals to AO plus OB. So in this direction, but we don't have, we have OA to be A. So AO will be minus A, then plus OB is equals to 2C. So write 2C like this. So we want to write 2C minus A, okay? It's okay, and you can write minus A plus 2C. So since I have this one now, then I can come back to this one. So AP ratio, so we have AP ratio PB, okay? So to be 4 to 1, okay? So now I can get AP and PB, okay? So the total ratio will be 4 add 1, okay? Total ratio be equals to 4 add 1, that will be 5. Okay, then the total length, they are sharing the total length, that will be AB, and we found that to be 2C minus A. So that will be 2C minus A. So we can now get AP. So AP will be equals to 4 over 5 of AB. So that will be 4 over 5 of 2C minus A in brackets. Okay, then that will be AP. Then PB will be 1 over 5 of AB, which is 2C minus A. So I can expand this later if I need to work with them. Okay, so now to get CB now, CB, so CB will be CA plus AB. So let's write it here. So this will be equals to CA in this direction plus AB in this direction. Okay, so if we go back to the diagram, we know AB, which is 2C minus A, but we don't know CA, so we need to firstly find C. We also know CA too. CA is minus AC. Okay, so that is what we need to do. So CA is the same as minus AC, then plus AB, okay, in this direction. So let's write their values now. So this would be minus C, then plus AB is 2C minus A. So if you solve this, this should be equals to C minus A. So we have C minus A as the final answer here. So the next one is to find OP. If you come to this place, OP will be this length. OP will be this length, and that will be the OP will be equals to OB plus POB plus BP. Okay, OB. So this will be equals to OB plus BP. So we know OB is equals to 2C, and we know PB is equals to this. Okay, so I can say that OP will be equals to OB is 2C, then plus this will be equals to minus PB. So that's what we're going to do. Okay, so I can just write this one like this: OB, then minus, let's write it better, OB in this direction, then minus PB. Okay, so if you substitute the values, this will be 2C, then minus, in bracket, 1 minus 1 out of 5. So in bracket, minus 1 out of 5 in bracket, 2C minus A. So let's expand the bracket. So this will be 2C minus 1 over 5, 2C, or minus 2 over 5 C straight away, then plus 1 over 5A. So if we solve this and this, if you add them together, so you should get 8 over 5C, then so you should get 8 over 5C, then plus 1 over 5a. So we can factor out 1 over 5. So it will be 1 over 5, then into, you can bring a first. That will be a, then plus 8c. So this will be the final answer for this question. Okay, so part D, we want to find QP. So Q, this is Q and this is P. So we can draw a line to connect them together. So to get QP, so we have many routes you can take, but I'll just take this one, QA plus AP. Okay, so I'll take it like that. I'll say this is equals to, so this will be equals to QA plus AP according to the diagram there. But if you scroll up a little bit, you can see that we have AQ to be equals to 4 over 5C. So this QA will be equals to minus AQ. So we can write this. Then plus AP. I think we have AP. Yes, this is AP here. So we are good to go. So plus AP in this direction. Okay, so it's good to always show the direction in vector. So this will be equals to minus AQ. That will be minus 4 over 5C. That is minus AQ. Then plus, then AP is 4 over 5 into 2C minus A. So that will be 4 over 5 into 2C minus A. So we can actually expand this. So if you expand this, you're going to get minus 4 over 5C. Then let's expand this bracket, plus 8 over 5C, then minus 4 over 5A. So they all have the same denominator, so you can combine them together. So for C, I'll combine C, so this will be minus 4 plus 8, that will be 8. So that will be 8 over 5C, then minus 4 over 5A. So I can factor out, this will be 4, not 8. So it should be 4 here. Okay, so I can factor out 4 out of 5. So this will be 4 out of 5. Then I'll be left with C minus A, like this. Okay, so Roman figure 2, use your answer to make two statements about the relationship between lines QP and CB. Okay, so let's go to CB. So this is CB. So CB, so let me write it here. CB is equals to C minus A. So vector CB equals to C minus A, and vector QP equals to 4 over 5 into C minus A. So this is a multiple of this, that is QP is a multiple of CB, so they are parallel. So I can say that QP, vector QP and CB, okay, are parallel because the QP is a multiple of, the value of QP is a multiple of the value of CB, so they are parallel. So another statement I can write is, instead of me to write 4 over 5, I can say QP like this is equals to 4 over 5. So instead of me to write C minus A, I'll just put 4 over 5 CB. So that would be the statements, the two statements I can write here. Okay, so let's go to the next question. That will be question 7. Question 7a. The diagram shows a field A, B, C, D with B north of A. BD is a path across the field. AB is equals to 85 meters and AD is equals to 72 meters. BD equals to 129 meters. Angle BDC equals to 39 degrees and angle BCD equals to 60 degrees. Show that angle CBD is equals to 81. So angle CBD, so that is this particular angle. We want to show that it is equals to 81. So you can see theta. So you can see these three angles are inside this triangle. So you can see that theta is equals to 180 degrees minus 60 degrees minus 39 degrees. Okay, so the value of theta should be equals to 81 degrees. So you can show that easily. Okay, so we're done with that. Roman figure 2. Calculate CD. Also calculate CD. Okay, so we can use, so this one is now 81 degrees now. So we can now use sine rule. Okay, sine, you can say CD over sine CD, that is this one, then equals to, or better still, you can write this one to be side B. So, and we know this one you can take it to be this. I think I'll use to create, in order not to create confusion, so I'll just use CD over sine CD. Okay, so I can say, okay, CD is equals to sine B, so we can write it here. So it will be CD, okay, over, okay, no problem. So we can use just side, this should be side B, okay, this should be angle B, so this should be, this is angle C, so this will be side C here, okay, no troubles. So I can just use that, so it will be B over sine B, then equals to C over sine C, okay. So here we have B over sine B equals to C over sine C. So let's substitute the values there. So we want to find side B over, then sine angle B is 81 degrees equals to C is equals to 129 over sine C, that is sine 60. So I can cross multiply and make B the subject of the formula. So B will be equals to 129 multiplied by sine 81. Okay, so everything divided by sine 60 degrees. So you can input this into your calculator, and the value of B should be equals to 147. Okay, correct, to 3 significant figures. So 147. Okay, so Roman figure 3 show that angle ABD is equals to 31.6 degrees. Okay, so that's angle ABD. So ABD. So we want to show that this angle, okay, is equals to 31.6 degrees. We want to show this. Okay, so we know this to be 72. Okay, so this is angle A. So this one will turn to side A. Okay, so let me just remove this now. So I will take it to be side A now, because I'm using this diagram. Okay, then this is angle B, so this will be side B. Okay, I may leave it since I'm not using that value. Okay, I can leave that as C. Okay, no troubles. So okay, okay, so this is angle A. So I think it's better to leave it as angle side A, because I'm using angle A. Okay, so I have A here, then this is side angle D, so this will be side D. So this is angle B, so this will be side B, so it's better to have it like this. So this is D. Okay, good. So we can use cosine rule, okay, straight away. So if you have the formula, you can just write, since we are dealing with cos B, so you can just write cos B equals to this one, a squared plus d squared, then minus b squared, everything over 2 into a into d. Okay, so you can write it straight away like that. Okay, so but if you cannot get it like that, you can start from here. So I like to write something like a squared plus b squared plus c minus a squared plus b squared. Sorry, if I'm looking for a side, so I'll just write b squared equals to a squared plus c squared minus 2 into a into c, then cos b. Okay, so from here I can make cos b the subject formula. So this is the only one I know, and from here I can make anyone the subject of the formula, either an angle or anyone. Okay, so if I need, let's say I need side A for instance now, so I'll start with A. So it will be A squared equals to B squared minus C squared minus 2 into B into C, then cos A. So this is very easy. So I did not memorize it, I just know the pattern. So from here I can make cos B. So I'm using this one. I can make cos B the subject of the formula. So and eventually I will get B. So I can say cos B. Let's write this now. Cos B will be equals to here it will be equals to a squared, but I'm using a, b, and d now. So it will be a squared plus, let me see, I'm using a, b, and d. So it will be a squared plus d squared minus b squared. Okay, so you can see this is why you have to understand it. Okay, not by just memorizing this. So it will be b squared into, okay, like this, then everything over 2 into a into b into d. Okay, so this is what I will have here, and eventually I can take cos inverse of both sides. So if I take cos inverse of both sides, so cos will disappear here, so I'll be left with b, then it's equals to cos inverse of a squared plus d squared minus b squared, everything over 2 into a into d. Okay, so this is what I'm going to use to get the value of that angle. So I can just key in the values now. Okay, so let's key in the values. So b is equals to cos inverse, rather this will be cos inverse. Okay, so a will be 129 squared, then plus d will be 85 squared minus b will be equals to 72 squared. So everything into 2 into 129 into 85. Okay, so you can actually put this into your calculator. Okay, the whole of this, you can put it in the calculator, and the value of b should be equals to 31.6 degrees. So pretty straightforward. Okay, so Roman figure 4, find the shortest distance from a to b. So the shortest distance from a to BD rather, so it will be this here. Okay, so this will be the shortest distance. So I can use, I can put this one to be h, the height here. Okay, so to do this, I will need to draw this diagram here. Okay, that is to have AB, and I can call this one probably M. Okay, so ABM, something like this. Okay, so let's go to the next page. So we can have a, let's take that again. So we can just have a, then a kind of b now, something like this. Okay, so complete this one. So just have a kind of a triangle, and I think I denoted this side to be M, so this should be A and this should be B. So this is the height. Okay, let me just write it like this. So this is the height. Okay, from A to M is the height, is the shortest distance we want to find. Okay, if you go back to the diagram here, so we have the angle here, 31.6. We have 85. Okay, so I want to get H here, so this is 85. Okay, so let's go back here. So here I have 85 here, and the angle here is 31.6. Okay, so this is opposite and this is hypotenuse, so this one is the right angle. So I can use sine theta, that is sine theta equals to opposite, okay, over hypotenuse. Okay, so it will be sine 31.6, okay, then equals to opposite, which is the height, okay, over 85. So if I cross multiply, so h will be equals to 85 times sine 31.6. So h will be equals to 44.5. So h will be equals to 44.5. So three significant figures. So that is, find the bearing of B from C. So we need to go back to the diagram again. So let's go back to the diagram. So we want to find the bearing of B from C. So here we need to do little adjustments. So let's try to do something like this, okay, to get the 4 cardinal points there. So we'll do the same thing for this one here. Okay, I think this is good. So we can do the same thing for this one here. Okay, good. So the bearing of B from C to be from here up to this line here. So we need the whole of this angle. Okay, so but we know that from here to here is 180. Okay, from here to here is 180. So we just need to get this angle, that is from here to here, that should be 60 plus something. Okay, so the problem here is we don't know this tiny angle here. Okay, this small angle. Okay, we need to find this angle. Okay, so once we know that, then we are done. Or alternatively, if, okay, I think I can extend this line very well. Okay, sorry, I'm trying to pick this line here. Come on. Okay, not you. Oh, okay, yes. Yes, I got you. So this particular one here. Good. So alternatively, I can easily get the whole of this angle from here, okay, up to this south pole. I can easily get that. So once I get that, I'll just add it to 180. Okay, so that will be the bearing. So let's see the one that will be very easy for us to calculate. So I think I can remove this one because it's too rough now. So we want to get the whole of this angle. Let's pick this one again, from here to here. So that is what we need. Okay, now there is something here. If you look at this diagram now, so we can make use of alternate angles. We can actually start from here, so from angle B. So let's scroll up a little bit. So you can see that the whole of this angle here from here to here is a right angle because this passes through the south pole, okay, to point A. Okay, so if the whole of this is 90 and this smaller one here, this angle here is 31.6. This is 31.6. Okay, so that means I can get this place to be 90 minus 31.6. So that would be 54.8. So this will be 54.8. Okay, this particular angle, let me just write, is 58.4. Okay, that is 58.4 if you do 90 minus 31.6. So, and don't forget that the whole of this angle from here, okay, to this place is 81. Since I know part of it to be 54, then I can do 81 minus 58.4. So that will be equals to 22.6. So that means this smaller angle here, this particular one, okay, let me draw an arrow here. So this particular angle here, from here to here, okay, will also be 22.6. So I'll put 22.6 here, okay. So this will help me. So I know that this angle here now, from here like this, okay, up to this line, up to this one now, okay, they are alternate angles. So this place will be equals to 22.6, okay, 22.6, okay. So I think I can now get this the smaller angle here, okay, this small angle here, I can get it. Or better still, so because everything here is also 90, let me draw this from here, okay, to this place is also 90. Can you see? So, and I know this place to be 22.6. So here to be 60. Then I can just take away, I can just subtract this, okay, from, I can just subtract 60 and then 22.6 from 90 to get the smaller one. Or another alternative is that this is what I want. I need the whole of this angle, okay. So I can just subtract 22.6 from 90. It will give me the whole of this angle from here to here, and that is what I need. So then I can now add them together with, that is when I find this angle. Okay, so let me call this angle, let me say alpha. So if I call this angle, that is from here to here, is alpha, okay. So I can say alpha, that angle will be equals to 90 minus, so we'll subtract the small one here, okay, minus 22.6, then alpha is equals to 67.4. So I cannot get my bearing now. So the bearing will be from here, starting from here, the angle from here up to this place plus, up to this place rather, because we have a line here, up to this place. Okay, good. So which is 180, then plus alpha. Okay. So I just did it here for you to understand the solution. Otherwise, I should have come down here. Okay. So let's go to the next page. Okay. So the bearing, okay, of B from C will be equals to 180 degrees plus alpha. So, and I told you that alpha, we found alpha to be 67.4. Okay, so everything will be 247.4 degrees. So we have 247.4 degrees. Okay, so but around figure C, trees are planted in the field. The number of trees planted is 1100, that is 1100 per hectare. So calculate the total number of trees planted in the field. So 1 hectare is equal to 10,000 square meters. Okay, so we need to firstly find area covered by the field. So we need to visit the Again, so here the area covered by the field will be area of this triangle ADB, okay, plus the area of triangle BDC. Okay, so that will be the area covered by the field. So let's calculate the area covered by the area of triangle ADB will be the base times height over 2. The base is 129 and their height is this. The distance, the shortest distance between A and then DB, which is this one. I think we calculated this to be 44.5. Okay, so that will help us to get the area of that triangle. Okay, so let's go down. So area of triangle A, let me see, ABD, I think yes, ABD should be equals to base times height over 2, and the base is 129 times the height was the shortest distance we calculated earlier, 44.5, then divided by 2. Okay, so this will give us the area, that is 2,870.25 meter squared. So that will be for this. So for the second one, area of triangle BDC, so area of triangle BDC, so will be equals to, let's go back to the diagram. So here we have these angles, that is angle 81. So I think I can remove this one now. Okay, I can remove this now. So I may return it later. So we have this angle to be 81 degrees. Okay, so we know this angle to be 60. So we know this angle to be 39. So we can actually use this formula where you have AB sine theta over 2. Okay, to get this now. So we have two sides. So we can use side 129. Okay, so this side, and another side we can use will be this. See, yes, this side B. We found side B to be, I think, 147. Yes, so this is CD, so this place is 147. So we can use this side and this side, and the angle between the two sides will be this. Okay, so that means the area of this one will be 129 times 147 times the sine of angle between them, that is sine 39, divided by 2. Okay, so I think I can return the diagram to how it was, since you understand the stuff there. So yes, I want to leave it like this. So let's go to the page. So the area of triangle BDC will be equals to the area of the two, the product of the two sides. So 129 times 147 times the sine of angle between them, that is sine 39. Okay, divided by 2. So you don't have to memorize any formula. You just have to, the only thing you need to do is to understand the formula. Okay, so if I input this into my calculator straight away, so I'll get the area to be 5,966.9 squared centimeters. So the area of the field now, okay, so will be the area of let's say ADCB. Okay, so that will be the area of everything, and it will be the addition of these two. Okay, so the area of the field, or the area covered by the field, okay, area covered, I think it's better like this, covered by the field be equals to the addition of these two, that would be 2,870.25 plus 5,966.9. So, and that will add up to 8837.1 meter squared. Okay, since I know the area covered by this, then we are given the what's it called, from here we have hectare. Let's use h for hectare. So I'll use, okay, h for hectare ratio, then meter squared, m squared. So it is 1 to 10,000. Okay, so now I have 8,837.1. Okay, so 8,837.1 square meter. Okay, so what was done to this to get this? Actually, it was multiplied by 8837.1, okay, over 10,000. Okay, so that's what we're going to do to this one too. It will give us the equivalent in hectare. Okay, so this will be times 8837.1 over 10,000. Okay, so that means the value here should be 0. You should get 0.8837. So that's what we get here. So 0.88371. So that would be the equivalent of the area covered by the field in hectare. Okay, so we can now calculate the total number of trees planted in the field. Okay, so that would be 0.88371 multiplied by the amount, that is 1100, because we have 1100 per hectare. Okay, so this is what we need to do, and this eventually will give us 972.08. Okay, so of course you cannot have a fraction of the tree, so you can either say we have 932. Okay, so you can say 972 rather, or you can say you have 973, because this fraction, okay, so will be regarded as a tree too, because probably it's still just growing. Okay, so you can use any of the two. If you like, you can write 972. If you like, you can write 973. So for me, I would rather choose 973, I think. So, but anyway, it's your choice to pick one. Okay, so part B, a rectangle has an area of 9,400 centimeters squared, correct to the nearest 100 centimeters squared. The length of the rectangle is 80 centimeters, correct to the nearest 10 centimeters. Calculate the upper bound of the width of the rectangle. Okay, from the area of a rectangle, so we have the area to be equal to length times breadth. So if we make the width, okay, W for the width, if we make the width the subject of the formula, it will be equal to A for the area divided by L for the length. Okay, so but we need the upper bound of the width. Okay, so the upper bound, the upper bound of the width, okay, let's say of W will be equals to the upper bound of A, then divided by lower bound of L. So that is how you get that. Now we need to get these bounds. So for the area, so it is 9,400 centimeters squared to the nearest 100. So that means you can count in 100. So if the area is this 9,400 then the next one will be 95 rather, because we are counting in 100, 9500, and the one before it will be 9300. So because we are counting in 100. Okay, so the lower bound is this will be the lower bound. Okay, the average of this, it should be 9300 add 9400 divided by 2. Okay, so this will be the lower bound. So LB for the lower bound, and this one will be the upper bound. The upper bound will be 9400 plus 9500 divided by 2. Okay, so you can do that. This will give me 9450. Okay, so we can just take it without writing anything here. So this will be 9450. Okay, I just have to show you this. So it's something you can get directly. So this will be 9350. That will be the middle of these two numbers. So this is the lower bound of the area, and this is the upper bound of the area. So we can do the same thing for the space. Yes, I can scroll down a little bit. So I can do the same thing for the length. Okay, so the length is 80 centimeters, and we are counting in tens. Okay, so the next one will be 90. Okay, and the one before it will be 70. Okay, so the lower bound will be the mid number here, which I can easily get. So this will be 75. So this is the lower bound, and the upper bound will be 85. Okay, so now I cannot get this the upper bound of the width. Okay, so will be equals to so I need to remove this. Okay, good, sorry. Okay, it will be equals to the upper bound of the area. So the upper bound of the area is 9450 divided by the lower bound of the length. That will be 75. Okay, so that will be equals to 126. So that is 126 centimeters. Okay, so it's pretty easy when you do it like this. Okay, so let's go to the next question. That will be question 8a. A bag contains 24 colored beads. Some are red, some are blue, and 10 are yellow. Okay, so that means yellow will be equals to y and is equals to 10. Okay, one bead is picked at random from the bag. So find the probability that the bead is yellow. That is 10 out of 24. Okay, so this will be 10 out of 24, which is the same as 5 out of 12. So we have 5 out of 12. So the bead is not yellow. It will be 1 minus probability that it is yellow, 1 minus 5 out of 12. So this will be 7 out of 12. Okay, so let's scroll down. Part B. Another bag contains 5 green marbles. So we can say G for green, and it is 5. Then 6 white. So W for white, and it's 6. And 4 black. So B for black, and it's 4. So the total is equals to 15. So find the probability that the first is marble. The first marble is black and the second marble is white. So we want to get the probability of B and W. Okay, so this will be equals to probability of B times probability of W. Okay, so it is picked without replacement. Okay, so without replacement, so that's very important. Without replacement, so this will be equals to probability of the black rather, to be equals to 4 out of 15. So I've selected 1, so the total is now 14 times y. W will be equals to 6 out of 14. So if you input this into your calculator straight away, so you should get 4 out of 35. 4 out of 35. Okay. So both marbles have different colors. So this will be the same as 1 minus probability, okay, that they have the same color. So this is easier, the same color. Okay, so let's find the probability of the same color. So probability of the same color, so that would be, okay, I can just write probability of can have green, that is GG, then or probability of white, okay, or which is addition, probability of black, okay. So this is what we need to do. So it will be equals to this probability of the same color. So we're going to have we know the something. This will be 5 over 15. That's for the first green. Then times the second selection will be 4 out of 14. Okay, so this is 1. Then plus if you go to the white, 6 out of 15 times 5 out of 14. Okay, and for the black, plus it will be 4 out of 15 times 3 out of 14. So this will give you 20 over 15 times 14, that would be 210, plus 30 over 210, plus 12 over 210, and this will simplify to 31 over 105. Okay, now so the probability that they have different colors will be 1 minus probability. So you can say probability, so probability both have let's say different colors, so because to 1 minus 31 over 105, so this will be equals to 74 over 105. So 74 over 105 if you input that into your calculator. Okay, so let's go to the next question. That will be question 9. So question 9, so f of x is given as this, g of x is given as this. So find f of 7. So this is straightforward. F of 7 will be equals to 2 into 7 minus 5. So this will be equals to 14 minus 5, and this will be equals to 9. So we have 9 here. So g of 7 will be equals to g of 9, because f of f of 7 will be equals to g of 9, because f of 7 is 9. So we are finding g of 9. So this will be equals to 9 squared minus 2 into 9. So this will be equals to 81 minus 18, and that will be equals to 63. So we have 63 here. So let's scroll down a little bit. So I want to find f inverse of f, that is inverse of f. So we can just say that let f of s, okay, let f of x to be equals to y. So that means f of x now equals to y equals to 2x, okay, minus 5. Okay, so let's make x the subject of the formula. This will be y plus 5 equals to 2x. So if I divide both sides by 2, so I have x. So x will be equals to y plus 5 over 2. So let's replace x with f inverse of f. Okay, so because so replace y with x plus 5 over 2. So the answer will be x plus 5 over 2. Then part B, find g f of x minus 3 times g of x. Okay, so what we can do here is pretty easy. So let's find g f of x. Okay, so that will be equals to, that means we have to, this means that we pass f of x into g of x. So g of x, don't forget that g of x equals to, okay, let's write, so g of x is equals to x squared minus 2x. Okay, so and f of x, let me repeat this one again, is equals to 2x minus 5. So anywhere we see x in g of x, so we put in f of x. Okay, so that means g f of x now. Okay, we are doing something like this now. So this is what we are doing. Okay, so it will be equals to 2x minus 5 squared. Okay, then minus 2 into 2x minus 5. So this is from x squared minus 2x. So f of x is our x now. Okay, so you need to expand this. Okay, so if you expand this, you should okay, I think I'm trying to leave this. Okay, if you expand this, you should get 4x squared minus 20x, then plus 25, then minus 4x plus 10. Okay, so that is minus 2 times 2x, that is minus 4x, minus 2 times minus 5, that is plus 10. Okay, so we can simplify this to minus 20x. See any error here? Okay, I think we are good. So this will be 4x squared minus 20x minus 4x, that is minus 24x. So plus 25 plus 10, that is plus 35. So this is this. Okay, so the next we need to do is to get 3g of x. So I can just partition this side. So 3g of x will be equals to 3 into g of x is equals to x squared minus 2x. So let's expand this. This will be 6. This will be 3x squared minus 6x. Okay, so to go back to the question now. Okay, so I can write g f of x minus 3g of x will be equals to 4 s squared minus 24x plus 35, then minus the whole of this, that would be 3x squared minus 6x. So if I expand that bracket, so I should have 4x squared minus 24x plus 35 minus 3x squared plus 6x. So if I simplify this, 4x squared minus 3x squared, that will be x squared. Then I have minus 24x plus 6, that is minus 18x, then plus 35. So final answer, x squared minus 18x, then plus 35. So that will be my final answer. Okay, so we are approaching the last question. That will be question 10. A curve has the equation this. Differentiate rather x cubed minus 9x squared minus 48x. So we want to do this. So that means we want to find the y, the x. Differentiate y with respect to x. This will be 3x. Then 3 minus 1, that will be 2. Then 2 times 9x, that is minus 2 times minus 9x, that will be minus 18x. Then 2 minus 1 is 1. Then 1 times minus 48, that is minus 48. Then 1 minus 1, 0. So x to the power of 0 is 1. So this will be the derivative. It will be 3 s squared minus 18x then minus 48. Part B, find the coordinate of the turning point of the graph of y equals to s cubed minus 9s squared minus 48x. So you must show your working. So at the turning point, okay, so at the turning point, so the y, the x is equals to 0. So the implication is that 3x squared, so it implies that 3x squared minus 18x minus 48 is equals to 0. So I can simplify this as I can reduce this by 3 because 3 can go. So I can divide 2 rather by 3. So this will be x squared minus 6x minus 16 equals to 0. Okay, so I have 8 times 2 to be 16 and minus 8x plus 2x will give me negative 6. So this will be x squared minus 8x plus 2x minus 16 equals to 0. So I can factor out x here, so minus 8. I can factor out 2 here, x minus 8 equals to 0. Okay, so here, so it will be x plus 2 into x minus 8. So let's write this one very well. X minus 8 equals to 0. So it implies x plus 2 equals to 0 or x minus 8 equals to 0. So x is equals to negative 2 or x equals to 8. Okay, so when x equals to negative 2, so y will be equals to, so I think I can write y again, y equals to s raised to power 3, I think minus 9x squared minus 48x, okay, so this will be equals to, so let's substitute the value of x there. So the value of x, so the value of x is minus 2, so that will be minus 2 to the power of 3, then minus 9 into minus 2 all squared minus 48 into minus 2. So from here, if you input this into your calculator, so when x is equals to minus 2, then y will be equals to 52. Okay, 52. So you have minus 2 comma 52. Okay, so for the second one, so when, so I think I can partition this like this, sorry. So when x is equals to 8, okay, y will be equals to, so let's substitute to this equation again. So y will be equals to 8 cubed minus 9 into 8 squared minus 48 into 8. So this will be equals to, you can input this into your calculator straight away and you'll get minus 448. If you do that, so that means you have 8 comma minus 448. So that will be the coordinate of the turning point. So part C, determine whether each of the turning points is a maximum or a minimum. Give reasons for your answers. Okay, so we need to get the second derivative. So we know that the y, the x is the first derivative and is equals to 3x squared minus 18x minus 48. So we can get the square y over the x squared. So it will be equals to, let's differentiate this further, it will be 6x minus 18. Okay, so what we need to do now, we need to get the square y over the x squared at x equals to, let's start with minus 2. Okay, so this will be equal to 6 into minus 2 minus 18. So this will be equals to minus 12 plus 18. Okay, and sorry, minus 12 minus 18, minus 12 minus 18, this will be equals to minus 30, and is less than 0. So less than 0, it's the implication of this is this. Let me sketch this. It means, let's say this is point x equals to minus 2 now. So since the second derivative is less than 0, that means after that point, after this turning point, so it begins to come down like this. So that's the meaning. So the implication of this is that it was actually increasing before the turning point. Okay, so I can use broken line. So it was increasing before the turning point. Okay, then after the turning point, okay, so it was or let's say it begins to decrease. Okay, so that means it is maximum. As you can see, this is for maximum and this is for minimum. So it is maximum point here. The point is maximum. So that means at so it's maximum at x equals to minus 2, y equals to 52. So it's maximum here. Okay, so we can do the same thing for the second one. We can partition this here. So the square y of the x squared at x equals to 8. Okay, so will be equals to 6 into 8 minus 18. So this will be equals to 48 minus 18, and this will be equals to 30, so which is greater than 0. So the implication is that at this point 8, okay, so let's say this is the point on the curve 8. So after the turning point, so it increases. That's the meaning of greater than 0. Okay, it increases. Okay, so the implication is that before the point, okay, it was decreasing. Let's use broken line. So it was decreasing. Okay, and you can see this point is a minimum point. So you can say it is minimum at x equals to 8, then y equals to minus 448. So it is minimum at this point. So this will be the end of my solution to the component 4 2. So watch out for the remaining components 4 2 4 1 4 3 respectively. Until then, have your fingers crossed.